Hello everybody, welcome into another lesson. Happy September, and for those who are my American friends, happy Labor Day. Hope you enjoy it. Have a good weekend. So today we are going to talk about systems of linear inequalities and how we graph those. So here we have y is less than or equal to 5, then we have x is greater than or equal to 1. So, how would you graph that system? Well, let's start with y is less than or equal to 5. I'm going to do the first equation in blue today. So since it's less than or equal to 5, that means we put a solid line at y equals 5. So we're going to... Yeah, nice solid line as I'm drawing it curved, right? Okay. So yes, we're going to draw a nice solid line at y equals 5. Alright, so there's the y is less than or equal to 5 part. Now we have to settle the x is greater than or equal to 1 part. So since it's greater than or equal to, you'll draw a solid line at x equals 1, which would be right about there. I'll show you the product here in a second once I finish this. Alright. So what we should see here are nice two solid lines. We have y is less than or equal to 5 and x is greater than or equal to 1. Now, what we have to do is we have to shade the region that meets both qualifications. It has to be less than or equal to 5. We already got the equal part, so we want to dip below the y equals 5, right? Dip below the y equals 5 since it's less than or equal to, so we know the region's going to be below the y equals 5 line, but it also has to be greater than x equals 1. So the only region that's going to meet both qualifications is roughly right over here. So I'm shading everything below y equals 5 and everything to the right of x equals 1. And yes, it's another one of those messy lessons today, but it needs to be taught. So my end result would be everything that's below y equals 5 and everything to the right of x equals 1 would get shaded. And I do got more. Yeah, this lesson's not going to be a pretty one, kind of like yesterday's. It wasn't very pretty, but it does need to be taught. Because this will come up in an algebra course. Good news is I don't think there's a whole lot of this in Algebra 2. It's mainly an Algebra 1 phenomenon where we're teaching this, but it does come in handy for if you're knowing which regions are... Like if you're trying to, I don't know, figure out regions or computer programming and stuff, it's good to know for which regions are affected of a coordinate area, which regions are affected. Okay, let's move on to the next one. We have y is greater than 3. Let me move this because it's going to be in the way. So we're going to do y is greater than 3. X is less than negative 2. Excuse me. So we have y is greater than 3, x is less than negative 2. We'll start with y is greater than 3. That means at y equals 3, since it's just greater than and not equal to, we're going to draw a dotted line at where y would equal 3. So draw a nice dotted line at y equals 3, because we're not going to include y equals 3 in the solution since it's only greater than. Alright. So yeah, since there's no equality with it, it's just simply greater than 3, there's a dotted line at y equals 3. A broken line. That denotes that we're not including y equals 3 in the solution. So far you should come up with that broken line. So we got y greater than 3. Next thing we have to address is x is less than negative 2. So that tells us we're not including x equals negative 2 in it. So we get another dotted line, a broken line at x equals negative 2. So draw your broken line there. Alright, so that's what you should see. Two broken lines, one running through y equals 3, and then another running through x equals negative 2. Now we got to do some shading. So it stipulates that y has to be greater than 3, so it's going to be somewhere above this broken line, but x has to be less than negative 2 also, which would have to mean it's to the left of that broken red line. So ultimately what you're going to do is end up shading this region here. This is the region that meets both qualifications that are given. So this is where y is greater than 3, but x is less than negative 2. You would shade that region right there. Alright, I even have more. I think I need to order some more erasers from Amazon at this point. I've really gone through erasers teaching these lessons. Just because we use so much ink on these. But it's a labor of love. Alright, what is the next one I'm going to do? Let's see. Y is less than negative 4, and then x is greater than 4. Alright, so we have y is less than negative 4 and x is greater than 4. So first we need to draw, since its y is just less than negative 4, it's going to be a broken line running through y equals negative 4, which would be about right there. So find y equals negative 4, draw yourself a broken line running through there. I know this is slightly crooked, I can't draw the straightest, but you'll get the idea at least. Alright, so there's the line for y is less than negative 4. Now we also have to address x is greater than 4. Since it's just greater than 4, that means you get another broken line through x equals 4. So we're going to draw that broken line through x equals 4 right now. come down here. Alright, so now we have our two lines. We have the broken line through y equals -4 and another broken line through x equals 4 because they're simply less than and greater than. There's no equality in it, so we don't want to include these values in our solution. Now we got to find the region to shade that meets both of these qualifications. So let's start with y is less than -4. Less than -4 means it's going to be below this blue line, so we know it's somewhere in there. And then the other qualification is that x has to be greater than 4. Well, we know it's below the blue line, but x greater than 4 means it's to the right of this red line. So the area you're going to shade is going to be right in here. Yes. It'll be right in here. That'll get you where you need to be. So shade that region that meets both of those qualifications and you have your answer. Alright, let's spice it up a little bit here. Whoops, did not mean to erase part of the coordinate plane. I've been trying to be so careful about that. I'll fix that here real quick. Now I'm painting the board purple. Alright. No biggie. Nothing that can't be fixed. There. Fixed as best I could. Alright. What would be the next one I'm willing to do here? Now, we have y is greater than 3x, and then x is less than 1. So now we got one equation that has two variables, y and x. Well, let's start with y is greater than 3x. Since it's just greater than, we're going to draw a broken line through y equals 3x. So let's see, 0, 3, -3. Hope we could see that all right. Yeah, I think we can. No, that's wrong. It's got to be a steep line, kind of ish. There. There's going to be y is greater than 3x. So, and then we also have to address x is less than 1. Well, so x is less than 1, that means that x equals 1. We just simply get another broken line. So we're going to draw a broken line through x equals 1. We'll do that real quick. Alright, so we got two things to address here. We got to now, since we've drawn both broken lines, we want to shade the region or meets both qualifications. So we start with y is greater than 3x. So that's going to be somewhere it's above the y equals 3x line, but it's going to be to the left of it, really. It's going to kind of tilt to the left. And then we got to deal with x is less than 1. So basically what that's going to be, it's going to be a little bit of a mess here because it's going to end up being this entire area down here. This entire area down here, of course, because it's x is less than 1, but it's greater than y equals 3x. And then you have a little bit over here where it still meets both qualifications. So yeah, it's going to be... And actually, it's going to end up being right where they meet there. Yeah, so it's kind of a weirdly shaded region because you go up to where it meets the 3x, but you don't want it to meet 3x itself, or y equals 3x, and then x is less than 1. So it's kind of weird how the shading works out in this case, but you want to find where it meets both qualifications. And I got more equations. I do got more. I'm not dropping you off on the cliff here, don't worry. I'm not going to leave you at a cliffhanger. Got to get some finer erasing here because the shading went a little funky. You can get some really funky shading sometimes. And you will have that sometimes, but that's okay. After all, this is not art, this is math, so no one's going to critique that. Alright, let's move on to, how about y is less than or equal to x plus 1. Y is greater than or equal to 2 minus x. So now we have both equations of the inequalities that both have two variables. So we have to start with y is less than or equal to x plus 1. Since it's got the equal component, we're going to draw a solid line through y equals x plus 1. So 0, 1, 1, 2. So let's draw that nice, well actually it's a solid line, I don't know why I'm drawing broken. Only for the fact that so many of these have not had the equal component. So since it's got the equal component, you draw a solid line through y equals x plus 1, because this time you do want to include that as part of your solution. Now, we also got to figure out y is greater than or equal to 2 minus x. Since it's got the equal component, you're going to draw a solid line through y equals 2 minus x. 0. Alright, so you're about to see just how funky this can get. Alright, so now we have both lines drawn. They're both solid since there's an equal to component. Now what we have to figure out, since you've drawn the lines, we got to figure out where y is less than or equal to x plus 1, which is that blue line. So less than that tells you it's going to be somewhere below this blue line. That qualification's met because we're somewhere in here. The other qualification is that y has to be greater than or equal to 2 minus x. So it's got to be above this line here, above the red line. So that tells you that your answer for shading is going to be this nightmare. I'm trying not to color over the axis itself, but yes, the axis would be included in that too. I'm just trying to keep the axis so I don't have to redraw it, but just know that the axis is in there also. But your answer for shading, it would fall below the blue line but above the red. So that entire region would end up being shaded for the answer. I'm going to have to fix that. There's just no way around it. That's what happens when you get into solid lines sometimes. Alright, let me fix my axis real quick. Fix that. Alright, there we go. I think we fixed it pretty well. What's the next one? Let's see. Y is less than 4x plus 4. And then we have y is greater than negative 4x plus 4. So another two equations here. So we have y is just simply less than 4x plus 4. That means through that y equals 4x plus 4 line, it's going to be a broken line because we don't want to include y equals 4x plus 4 in the solution. So now we need to find the line. Negative 1 would be 0. There we go. Draw your nice line through there. A nice broken line, because that's what you're going to get since there's no equality in this. Alright, so there's the first line through y is less than 4x plus 4. Now we need to do y is greater than negative 4x plus 4. Well, that's also going to end up being... You know what? I need to draw this line a little better. It's bugging me. I'm sure it's bugging you too. Let me fix that line here, because sometimes I don't draw it the straightest and it's harder to see in a big area. So bear with me a minute, please. I want to give you a straighter line. Okay. At 0, 4, negative 1, 0. How's that so far? Not as bad. Not quite as bad as what I had, I don't think. It's not as bad. Alright. Then y is greater than negative 4x plus 4, so through y equals negative 4x plus 4, we draw another broken line. Let's see, 0, 4, 1, 0, okay. Alright. So now I have my two broken lines, which aren't the prettiest drawn, but it'll suffice. Okay, so now we've drawn our lines, we got to figure out the region to shade. So, what we're going to have here is y is less than 4x plus 4 is that line in blue. That means it's got to be below the blue line, which would actually be to the right of it. That would be everything for the y is less than 4x plus 4, meet that qualification. The other qualification is that y is greater than negative 4x plus 4, which would have to mean it's everything to the right of that red line. So what you're going to get to shade is a really big area. It's a really big area here. Yeah, it's not the prettiest, but it'll suffice. So what we've just done is shaded everything below the blue line, in this case to the right of it, because the way it's tilted, it looks like it's to the right of it. That would be less than 4x plus 4. And then we've shaded everything to the right of the negative 4x plus 4 line in red. That's where your y values would be greater than negative 4x plus 4. So the area that meets both of those qualifications are this. Is this, rather. That one we're going to I have about 2 more problems and that's it. 2 more problems and that should do us for the day. let's see what we got in store here. As soon as I fix this coordinate plane, that would kind of be important to be fixed, right? Another one here. Alright, I think we got it. Two more problems. Y is greater than 2x minus 3, but y is less than 2x plus 6. Alright, so we have y is greater than 2x minus 3, but y is less than 2x plus 6. So since there's no equality, it's just greater than or less than, each of these will have a broken line through them, going through the points where y would equal 2x minus 3. So let's start with that. Let's figure out that line. At 0, it's negative 3. 1, it's negative 1. And at 2, it's 1. Okay. Just trying to draw some nice guides here to help me. So I can kind of keep this straight. That's my ultimate goal, is to keep this straight enough so we understand it. Oh boy, I really veered off the path there. I really veered off the path. I think it's going to go something like this. Just trying to make sure it doesn't look so crooked. That's a lot better. Alright. So there's your y equals 2x minus 3 in a broken line. Since it's just greater than, we definitely don't want to include it in the solution, so that's why it's a broken line. Now, we also have to figure out y is less than 2x plus 6, which means through that equation there is yet another broken line. So let's see. So 0 would be 6. Through 1 it would be 8. Negative 1 would be 4. Let's start connecting this here piece by piece. Alright, and then what else are we going to have here? Negative 2 would be positive 2. Negative 3 would be 0. Okay. Well, we're about to discover something very interesting about these lines. I'll talk about it here once I'm done drawing them. Some of you may have already figured it out here, as crooked as these are, but notice both of these lines have the same slope but different y-intercepts. These are parallel lines. That's why they don't appear to meet, because they both have the same slopes but different y-intercepts. Therefore, these lines are parallel. So these two lines will not cross. Now, we want to figure out where y is greater than 2x minus 3. Well, y greater than 2x minus 3 would be everything above the 2x minus 3 line, or I should say to the left of it, to the left of the blue line. So we know it's now somewhere in this region. But we also want y is less than 2x plus 6, which would be below this red line. So your shading is going to go in between the two lines. That's what you get. The shading actually occurs between the two lines here. Put a little bit there for all fairness sake. So yes, you can get wild shadings like this. And that would be your shading. It would just fall between the two lines. And I do have one more. Just gotta get through, so trying to destroy this axis as much as possible. The less I have to redraw, the better. I think you'd all agree with that one. The less we have to redraw, the better. Alright, there we go, I think. We got it now. Alright. Put one here. Put one there. Put one here. Alright, I think that'll suffice. No, it won't, because I gotta draw that. I think that's all the broken axis. Alright, last problem. Y is less than 5x plus 3. So now we got y is less than 5x plus 3. But y is greater than 5 minus 5x. So we got these two inequalities here. Y is less than 5x plus 3. And then y is greater than 5 minus 5x. Well, start with your first line. Y is less than 5x plus 3 means it gets a broken line since there's no equal to component. So figure out that line. So at 0 it'd be 3. At 1 it'd be 4, 5, 6, 7, 8. So let's connect these dots. -1, it would be -2. That's roughly what it's going to look like. Okay. Alright, so there's the first line in blue. Y is less than 5x plus 3. The second one we got to figure out is y is greater than 5 minus 5x. Well, we also want to draw a broken line through that because it's just greater than. There's no equal. So at 0, it's going to be 5. At 1, it's going to be 0. Alright, then we'll just go up through here, and that should give us our nice broken line. Alright, so there's our two lines that are broken. Now we have to figure out where to shade. That meets both qualifications. So we need to figure out, alright, y is less than 5x plus 3. That's denoted by the blue line. Well, y is less than. That means it's going to be everything below the 5x plus 3 line, or in this case to the right. So we've identified it's somewhere in this area. Now, what also has to be true is that y has to be greater than 5 minus 5x, which would be actually above the red line here, which would be to the right of it in this case. So your shading that meets both qualifications is going to look something like this. Yep. Sometimes you can get small areas, sometimes you can get big areas. Really depends what the inequalities are, but that would be your shading. Alright. And if you're unsure whether a point's below or above a line, or if it looks tilted to the right or left, what you got to do, all you do is take an x value, right? See what you get for y. Take an x value, put it into your equation. You'll get a value for y. See if it gives you a true statement. If it gives you a true statement, you're in the right area. If it gives you a false statement, you need to go the other way. You're in the wrong area. So that's how you'll be able to test for below or above, left or right, what have you. That's how you test for that. But that's it for solving these inequalities. That's it for the messiness. Next lesson, we're going to do some numbers here. We're going to do like a number that is halfway between 2 and 8, for example. Or find a number that is a third of a way from 5 to 17. We're going to do a lesson on stuff like that, so you'll be able to handle stuff like that. So I hope everyone has a good day. Happy Labor Day. Take care.